If you're like some of the people I know, you start off your day by brushing your teeth, then you get ready for the day and go to school. You come back from school, take a break maybe, then you stay up doing homework, and then you watch TikToks until you no longer can, and then you sleep. You wake up the next morning, brush your teeth, get ready for school, go to school, come back, take a break, stay up doing homework, watch TikToks until you no longer can, then you sleep. You repeat again. But one fine day, you graduate from school, the cycle ends, and your life changes. And before you know it, you're off to college doing something else. That's what a loop is like. You conduct the same process each time as long as a certain condition is true. In our example, the condition was just going to school, but one day you didn't, and so you broke out of the loop and life took its turns. Previously, you learned about for loops, where the for loop had an initialization, a condition, and an incrementation. Now, there's another type of loop, while loops. While loops are a little easier in that it basically only has one condition as shown with the compared code here. You have a lot of freedom with what you want to do as long as you have that condition. So they're certainly a powerful tool, but as a wise man said, with great power comes great responsibility. To introduce while loops, I want to show you an interesting problem with numbers. This algorithm works with any numbers, and it's called the Collatz Conjecture or 3n plus 1 conjecture. In this continuous process, for all natural numbers or positive integers, if the number is even, you divide that number by 2. If it's odd, multiply that number by 3 and add 1. Then you continue with this process, and what's interesting is that you always end up getting the number 1. You can test it out with many numbers by hand if you wanted to, but with your computer, we can test as many cases as we want in an instant. As you can see here, I've got everything set up, and I want to use a while loop to replicate the Collatz conjecture. So first, obviously, we have the number that we want to test, so let's type in num equals some random number. I guess I'm just going to use 567. And with our while loop, it's very similar to how we started in the for loop. So we would type while, then 2 parentheses, and then 2 curly braces for that while block of code. So what goes inside these 2 parentheses is just the condition. If it evaluates to true, it will run the block of code between these 2 curly braces, and then I'll read this condition again. If it's false, this block of code is not read, and the computer simply moves on past this while loop to other lines of code if there are any. You're going to have to trust me on the fact that the number will always reduce to 1, so we can put the condition as num equals 1. So remember, the exclamation and equal sign together represent the not equal to relational operator. The expression num not equal to 1 evaluates to a value of either true or false. So if num is not 1, the expression is true and the code in these 2 curly braces run. If it's not, the computer just leaves the while loop. So within the while loop, if the number is even, so if num modulus 2 equals 0, we divide num by 2, so num equals num divided by 2. Remember, from our operators tutorial, we can actually just type num divided equals 2, which divides num by 2 and assigns it back to the variable num. Else, meaning the number must be odd, so we do num equals 3 times num plus 1. And just for fun, I want to type system.out.println num to see the process of how the number transforms. Right now it's 567, and we would expect the last number printed out to be 1. If we compile and execute our code, we get this long list of numbers, and it ends in 1. So when the variable num was assigned to the value 1, it failed this condition, and the computer stopped reading the while loop code, and the program just ended there. Test it with as many numbers as you want with the Collatz conjecture, because the interesting part is that the reason this is called a conjecture is because there has been no confirmed proof of this algorithm. To mathematicians, it just seemed right. Computer scientists have already dealt with this simple code, but no matter how many numbers they try, they don't necessarily confirm that this is true for all numbers in the real world. So if you're able to find that one number that does not simplify down to 1, you'll be able to debunk the Collatz conjecture and mesmerize mathematicians all around the world. See you in the next tutorial.